Hi, my name is Nahomi González and I'm going to present the evidence 2 of matter and energy. The topics we're going to see are charges, electric field, potential energy, and electric potential. So the first problem says that we have two spheres, each one of a charge of 3 times 10 to the minus 6 coulombs, and a distance of 100 millimeters. So the problem asks us what is the force of the attraction or rejection, and also if they are attracting or rejecting. So we're going to use the formula of force equals to K, the constant of K, times the charge number 1 times the charge number 2 over the distance to the square. So here we have the procedure, and also we can see that they are rejecting each other. The problem number 2 says that we have two small copper spheres, each one of a mass of 0.018 kilograms and a distance of 50 centimeters that separates each other. So the first question asks us how many electrons does each sphere contain. They give us the copper atomic number of 29 and the molar mass. So to get the electrons, we have to divide the mass over the molar mass, and then the result we're going to multiply it by the atomic number. So here is the result. And for the second question, how many electrons we have to take up from one sphere and add it to the other. So the attractive force of 3 times 10 to the 2 newtons is generated. They also say that the spheres are point charges. So we use the formula of charge equals to the square root of distance times force over the constant of K, and here we have the result. And then the problem 3 says that a charge of 4 times 10 to the minus 6 coulombs is placed at point P within the electric field, experiences a force of minus 8 times 10 to the minus 4 newtons. What is the intensity of the electric field? Here we have a simple formula of electric field equals to force over the charge. And here we have the result. For the problem number D, we have to get the electrons traveling at horizontal speed of, here we have the speed, that enters in an uniform electric field. For the question number 1, the magnitude and direction of the electric field at distance of 28 millimeters, we have to use the formula of the electric field equals to 1 over 4 times P to the epsilon 0 times charge over distance to the square, and the direction is to the right. And to the second question, what time does it take to the electrons to stop? We use the kinematic equations. So first we get the first part, and then this part is in here. We have to clear the formula for time. For the problem E, we have to demonstrate that a field outside a charged solid sphere is applying the Gauss law. And the distance r from its center has the following formula: E equals to the constant K times charge over the direction square. And then we say that the electric field of the point can be obtained by Gauss law because the electric field has the same magnitude at every point of the sphere, and the direction is outward. And here we have the equation. For the problem F, we have how many excess electrons must be added to a plastic solid sphere. Here we have the sphere with a diameter of 0.26 meters and the electric field of 1030 newtons over coulombs at the edge of the surface. So for the question number 1, we use this formula, the square root of the electric field times the distance over constant K, to get the electrons. And for the question number 2, that the charge is uniform and they ask us the electric field at 10 centimeters from the center, we have to use the formula of electric field equals to constant K times charge over distance to the square. For the problem for the problem G, we have two copper plates, and they are separated by 0.05 meters. The electric field generated by them is 5 times 10 to the 4 newtons over coulombs. So they access the work performed by the electric field when the charge is 5 times 10 to the minus 6 coulombs, and it moves from the negative plate to the positive plate. The work is equal to the charge times the electric field times the distance. So here we have the result in joules. And then in the H problem, they ask us the electric potential when the point is at 0.05 meters at a charge of 8 times 10 to the minus 6. So here we use these formulas of electric field and potential, electric potential. And then we have the result. Also, the number B, the letter B of the problem H, asks us the potential energy of a charge at the same point. So we use the electric field and the electric potential formulas.